Hello, friends. In the previous video, we analyzed quadratic functions. We found lots of properties like vertex, intercepts, axis of symmetry, concave up, concave down. So we learned these techniques. Now we're going to apply them to problems in physics and some math and some accounting. Hello, everyone. This is the second video in the quadratic function series. Here we solve problems using what we learned from quadratic functions. Okay, so let's see some problems and how we solve them. So here's the first problem. We have a farmer that has 800 meters of fence. So that's the length of the fence that the farmer has to enclose a rectangular field. What are the dimensions of the rectangle that produce the maximum area? So in these problems, it's usually good to draw a representative picture. So here's the field. I'm going to assume one side is y, one side is x, just a rectangular field. Okay. And now we know that the area of this rectangular field is x times y. But we don't know what the area is. I mean, we don't know x or y, so we can maximize the area. And again, here we're talking about maximum in the context of quadratic functions. Okay, we don't see the quadratic function yet, but all we've learned is in these two videos, or in the previous video, is dealing with quadratic functions, and there is an instance when the quadratic function has a max. That is basically an inverted parabola. Okay, so if we look at the inverted parabola, well, it looks like this. And then here is the max that we're looking for, okay? So, obviously we want to maximize this, but this equation does not resemble anything that we did in the previous video. But we're given another piece of information. We're given this, that the fence is 800 meters long. And physically, this represents the perimeter, of that rectangle. So the perimeter, which is 800 meters, is going to be 2y plus 2x. All right? Here's a y, here's another y, here's an x, here's another x. So now we can relate x and y from here and then substitute here, and then we'll see how the quadratic equation will form. Okay? So we take this and we divide by 2. So we get 400 equals y plus x. So let's solve for y and plug into a. So from this equation, y equals 400 minus x. When we plug that into a equals x times y, which is 400 minus x. Okay? So let's expand this. A equals 400x minus x squared. And if we rearrange, it will be negative x squared plus 400x. All right? And now we can see this is a parabola with a negative coefficient for x squared, right? So it's inverted, okay? And now we can find the coordinates of the vertex. So this is B, this is A, and C is 0. We don't care about C right now, okay? We can find the coordinates of the vertex as, remember, negative B over 2A, f at negative b over 2a. Okay? The function evaluate. This is where the maximum happens. This is the value of the maximum. But the problem asked for the dimensions. So we need to find this x dimension right now. So the x for the vertex is negative b over 2a, or negative b is 400 over 2 times a is negative 1. So that's 400 over 2. The negative gives me a positive, so that's 200 meters. So the x dimension, this dimension, is going to be 200 meters. So what is y? Y is 400 minus x, or 400 minus 200, or 200 meters. So it's going to be a square. So basically, the answer is x equals 200 and y equals 200 meters. Don't confuse this y with the function, right? Y equals something, right? These are just variables here. We could have used maybe length and width, L and W, same thing, okay? My function is A. Our function is A, okay? So there's the answer. Let's look at the next problem. So we have a farmer with 400 meters of fencing, wants to enclose a rectangular plot, but one side of the plot borders a stream and will not be fenced. So if we were to draw this, so say this is y, this is x, this is x. There's no fencing, this is the stream. There's no fencing along the stream. What are the dimensions of the plot that yield the maximum area? Okay. Again, it's the same problem as before, where the area is x times y. And in the context of quadratic functions, we expect the area to be an inverted parabola so that the vertex is the max. Okay. So what is the perimeter here? The perimeter is 400 meters, but in this case, we have 1x, 2 x's, and only 1 y. So it's 2x plus y. Okay? That is what we have for the perimeter. So from the perimeter equation, we solve for y. Y equals 400 minus 2x. Right? Bring the 2x over. Now, from here, we can plug y into a. So a equals x times 400 minus 2x, or 400x minus 2x squared. And let's rearrange so it can look in a standard form. Here's my a, here's my b. Yes, it's an inverted parabola. So we'll say a is an inverted parabola. B is the max. The vertex is the max. So what's the x coordinate at the vertex? Is negative b over 2a. So it's negative 400 over 2 times negative 2, which is negative 400, sorry, plus 400 over 4, or 100 meters. So x is 100 meters. So what is y? Y was 400 minus 2x, 400 minus 200, because x is 100, 200 meters. So the dimensions will be x equals 100 meters, y equals 200 meters. These are the dimensions of the plot that gives us the maximum area. Okay. Let's look at this. This is a financial problem. So the price per unit of a certain product is P equal 25 minus 0.1x, where x is the number of units of that product. Okay. So we're given the price. X is the number of units. Find the revenue. Let's just start answering them in order. Find the revenue. What is the revenue? The revenue is basically if you have a certain amount of items, okay, and you sell them at a certain price each, then the revenue is the price per item times the number of items, right? You have 10 bikes at $100 a bike. If you were to sell them all, how much would you bring in? It's 10 bikes times 100 per bike. You'll bring in $1,000. That's the revenue. But now we're given the price as a function of number of items. So let's plug it in. 25 minus 0.1x times x, expand. 25x minus 0.1x squared and rearrange. So that is negative 0.1x squared plus 25x. Again, this is A, this is B. How many units must be sold to maximize the revenue? In other words, what is X for the maximum revenue? And again, we see here, R is an inverted parabola. No, A is less than 0. Right here, here's A is negative 0.1. So V, the vertex, is the max. And now, vertex is the max. We can get the x coordinate of the vertex, and in this case, it represents the units, the number of units. So for part B, x equals negative b over 2a, or negative, what was b in this case? 25 over 2 times negative 0.1. So that's 25 over 0.2, or 25 times 5, which is 125 units. So the maximum revenue happens at 125 units. If we sell that, that's when we bring in the maximum revenue. Well, how much will we bring in? What is the maximum revenue? Well, now that I know x that brought me the maximum, these are the maximum revenue, so I'll plug it in, R at 125. Okay? Remember, our function here is R. Remember what the vertex was in method 2? There are the coordinates of the vertex. So I'm looking for this. How much revenue will I get? So that will be negative 0.1 times 125 squared plus 25 times 125. Okay? So we have to be careful, again, to make the relationship between what we're doing now and what we did in the previous video. The variables change, but the concept does not change. Okay? So when we put this in the calculator, we would get, I'm putting it here real quick. We will get 1562.5. Assuming this will be in dollars. Okay. So it will be 1652.5. That's how much revenue we bring in. Then they ask us, what is the price? What is P when the revenue is max? So again, the same thing will happen. We could say P equals 25 minus 0.1 times 125, right? Because now X is 125 units, which gave us max revenue. So what's the price per unit to achieve the maximum revenue? So this is 25 minus 12.5 or $12.5. So when we price the unit at $12.5 and we sell 125 of them, that is when we maximize the revenue. And the maximum revenue is 1562.5. Okay. All right. Oh, looks like I wrote on this page inadvertently. Okay, that's fine. I'll erase this, and then let's look now at a physics problem. So physics problem. We have a rocket height in feet above ground as a function of time is given by this equation. The height of the rocket is negative 16t squared plus 96t plus 256. Again, this is like f of x equals ax squared plus bx plus c. The variables don't matter. It's the concept that we need to apply here, the same as, apply to this as we applied to this in the previous video. So we need to be able to make that connection, okay? So our variable here is t, not x, which is fine, okay? Find the maximum height of that the rocket reaches, and then how long before it hits the ground. Well, again, if we look at this, h is an inverted parabola because a is negative 16 and less than 0. So the vertex is the max. And remember what the vertex is? Negative b over 2a. In this case, h at negative b over 2a. This is the time. This is the height, if you want to call it y, whatever. H. Okay? This is the function. So let's go ahead and find the time. We have to find the height that the rocket reaches. In other words, we want this. We want h at negative b over 2a. What's negative b over 2a? Here's t for the vertex. It's negative b over 2a, negative. B, this is b in this case. And this is b right here. This is a. Okay? So b is 96. Okay? And a is negative 16. Okay? So let's let's put it up here. Oops, it's not working. Here we go. Negative b is 96 over 2 times negative 16. The negatives cancel to give me a positive. So, and then we'll have a 32 in the denominator. So 96 over 32. Well, that one is easy to do. This is 3 seconds. So after 3 seconds, the rocket reaches, excuse me, the maximum height. Well, what is the maximum height? So it says h at 3 seconds. So we have negative 16 times 3 squared plus 96 times 3 plus, what was the last one? 256. So if we put this in the calculator, we negative 16 times 9, right? 3 squared is 9. Then plus 96 times 3 plus 256. And we will get for that 400. Feet, I'm sorry, not meters. Rocket reaches 400 feet. Okay? And then what do they want? So the maximum height of the rocket is 400. How long before it hits the ground? So when it hits the ground, again, let's look at the definition. A rocket height, or a rocket's height actually, in feet above ground. So when h is 0, that's when the rocket hits the ground. H equals 0. So let's set H equals 0. So we have 0 is negative 16 t squared plus 96 t plus 256. Okay. So let's go ahead and divide by 16. See if you can divide by 16 throughout. Negative 16. So that will give me a t squared. I'm going to rearrange right away. Minus 6t. And then here I'll have 16, 256, 16. Minus 16. Right? I divide by negative 16 everything. The left, 0 over negative 16 is 0. The right transforms to this, and then I swap the equation. So now we can factor this out. T, negative 8 here, plus 2 there. So basically, t equals, or here, t plus 2 equals 0, or t minus 8 equals 0. T equals negative 2 seconds, or t equals 8 seconds. Obviously, we cannot take time to be negative, because again, when we start timing things, when the rocket starts taking off, we start at 0 time. Okay? And t equals 8 seconds. So basically, t equals 8 seconds is the time the rocket gets back to the. Okay? Right? Mathematically, this is correct. T equals negative 2 seconds and 8 seconds. Those are correct. That's when we have a 0 height. But for our problem, t is greater than 0, so t equals 8 seconds. Okay? So the parabola may look like something like this. There's the parabola. Okay? It look better maybe. So this is the 8 seconds. This is time. And there's the negative 2 seconds right here. Mathematically, it's correct. And this is where we start from. That's the 256 feet. Goes up, reaches 800 feet. Was that the total? 400 feet, the height. Then it starts coming down. It takes it from here to the max, from here to there. Takes it 3 seconds, then 5 more seconds to come down. The whole trip takes it 8 seconds. Okay? Again, we're not going to solve it. There'll be more lectures on physics and things like this. Right now, we're just going to apply quadratic formulas. And mathematically, this is it, except we have to realize that negative 2 seconds doesn't make physical sense in our problem. Okay, let's look at this one right here. Soccer ball is kicked from the ground, either from a height of 0, and its height in meters is given by this function. So h of t is negative 5t squared plus 50t. There's A, there's B. This is an inverted parabola. So the vertex is max. Okay? Those are the first things we realize in this problem. Find the maximum height the ball reaches. Similar to the other one. Okay? The other one had a term right here, a third term, but this one doesn't have it. But so what? The coordinates are negative b over 2a, that's the time. And then the height is when we evaluate the function at negative b over 2a. There's the height. So at what time? Find the maximum height. Okay, do it the same way. T is negative b over 2a. Okay, so it's negative 50 over 2 times negative 5. What is that? The negatives cancel, so that's 50 over 10, or 5 seconds. So 5 seconds, it takes it to get to the maximum height. So what is that maximum height? H at 5. So that's negative 5 times 5 squared plus 50 times 5, right? Because t is 5. So 5 squared is 25 times 5 is 125. 50 times 5 is 250. So I'm going to get 125 meters. Okay? 125 meters. And then the last one, they say, how long before it returns to the ground? Well, it's the same one as before. H is 0. But what was H? 0 equaled negative 5 t squared plus 50t. Well, we can factor out a negative 5t here, and we will have a t plus a minus 10. So two things are 0, so negative 5t equals 0, or t equals negative 10, so t minus 10 equals 0. So from the first one, t equals 0, or t equals 10 seconds. Obviously, we'll take this one, because that's the later time. Yeah, so if here's the situation. Here's the ball being kicked from ground level. At t equals 0, it is on the ground. That's what that represents. Because again, they told you a soccer ball is kicked from the ground. So that's what this time represents. It goes up, comes down right here. It takes it 10 seconds to get there. And it goes to a height of 125 meters. And it takes it 5 seconds to get there. Right? And again, you could see the symmetry in the parabola. If from here to there, it takes it 5 seconds. From here to here, it's going to also take it 5 seconds. And that's what the symmetry we talk about. This time from here to there, this is the axis of symmetry. So let's extend this parabola like this. The distance from here to there had to be from here to there as well. We didn't have to solve this. We could just make the argument that they are on the same level. So it takes it 5 seconds to go from here to the maximum height. Now from the maximum height, which is the vertex, to the same level, which is the ground, is going to take it the same amount of time. And in this case, it is another 5 seconds. So a total of 10 seconds. Okay? That's the insight that we need to start looking at this, especially when we solve physics problems. Okay. So there'll be a series of videos on kinematics where we leverage the physics and try to interpret the math properly using this type of analysis. All right, thank you for your time. I hope this was beneficial. Again, please like, subscribe, and share, and check out our new videos. They'll be covering many topics: physics, math, chemistry, computers, and we appreciate you spreading the word. Thank you and goodbye.